Hi all, 5N1. This is a new topic on magnetism. Before I run through or start the lesson with you, we'll need you to have your notes as well as your pen and or pencil to get ready to fill in any keywords that we highlight, okay, along the way. Let me first of all run through the objective very quickly with you. As you can see, there are A, B, C, D, E, F of objectives to be met for this lesson. So what do you need to know in this chapter? First part of it, part A, state the properties of a magnet. You must be able to describe what makes a magnet. Okay, how do you convince me that a piece of uh, a metal that you're holding in your hand is a magnet? It must be able to exhibit three properties. So part A, we will learn about that. Part B, you must be able to describe induced magnetism. This is a new term you learn, and we will talk more about it later on. Then next, describe the electrical methods of magnetization and demagnetization. How to turn something into a magnet or to turn a magnet into a magnetic material again. All right. So that's A, B, C. Next will be part D, distinguish between the properties and uses of temporary magnet, for example, an iron, and permanent magnets, example, steel. So you'll be learning about iron and steel, these two. Then the objective E, there'll be to draw the magnetic field pattern around a bar magnet and between the poles of two bar magnet. Okay, very simply these two. And F will be to describe the plotting of magnetic field lines with the compass. As we go along, the order may be different, okay? But A, B, C will be mostly the same sequence. And let's quickly uh, start with the properties of magnet. What are the three basic properties of a magnet? Let me pause here for a while to look at the first video clip. All right, in this first video clip, you see a box of iron fouling. This plastic box, contains the iron fouling in a liquid oil, and you see immediately what happens when we speed up the process. This is the three-dimensional effect. And let me pause very quickly here for a while and tell yourself what you have observed. Okay, I think it's very clear that we see that there are two ends that attract the most amount of iron fouling, right? So what must a piece of magnet have? First, properties. I think we can see very clearly that the magnetic forces are strongest at two ends. And make a guess, what do we normally name these two ends as? Correct, okay? It's north and south pole. It must have two poles at the end, which the magnetic strength or magnetic forces is found strongest at. Let me now go back to your notes. Okay, so now back to your notes. The first properties that a magnet must have is it must have two poles. And these two poles are north and south poles, and these are the strongest part of the magnet. The poles are found very near to the ends of the magnet, not exactly at the end of the magnet. So even if you tried it out with the paper clips, you know that a big number of paper clips can be attracted at this north end and the south end, but you notice that none of them are attracted at the center part of the magnet because that's where there is no magnetic forces. okay, it is not strong there. In fact, if you put a piece of iron nail here and let go, the iron nail will automatically be shifted either to the left side towards the North Pole or to the right side to the South Pole end. Center part will always attract nothing. Okay, now before we look at the second property, whereby we hang a piece or suspend a piece of magnet freely, let's see what happened. Okay, first of all, this guy will explain with the compass on the table where is the north end and the south end in this room. Okay, then he will suspend the magnet at this place, and you see what happened.
It should point in that direction, and the south pole of the biomagnet should be pointing in this direction. We will see that now. Okay, here is the suspended biomagnet. So it should finally align itself in the direction which we saw before. Okay, to speed up the process, I will just allow it to hang freely. You can see that the north pole is trying to align in that direction and the south pole this way. Okay, we'll quickly, okay, so you can see.
Okay, class, the reason why he wants to use his hand to hold it a little bit is because it takes a long time for a freely suspended magnet to come to a standstill. But no matter how you push the magnet or disturb it or even make it spin, when it comes to rest, eventually it will always come to rest with the North Pole pointing towards the north end of the room, and the South Pole pointing towards the South Pole South Pole of the room. Okay, following the compass. Now, what does that tell you about a piece of compass? What does that tell you about the compass needle? What do you think? Okay, that means a compass needle is also a magnet, because compass needle behave the same way as a freely suspended piece of magnet. Do you get it? You can write that down into your notes, that a compass is actually a magnet. Okay, let me go back to your notes now. Okay, now back to your notes now, yeah? Okay, second properties. So if allowed to swing freely, a magnet will come to rest with one end pointing towards the North Pole, the Earth North Pole. So if it is in a room, you will know where, and with the help of a compass, you know where the North Pole is pointing. Then when you freely suspend this magnet, the North Pole will point towards the north end where the compass was pointing in that room. So the other end, therefore, of course, is known as the South Seeking Pole, South Pole, or in short, the S pole. So in this chapter, you have the right to write in short. If you don't want to write South Pole in full, you can write S, then dash with the pole, or in short form. Now we look at the third properties. Okay, just a reminder again, altogether there are three properties. So the next point. Now, what is this third properties? I think it's something that you are very used to playing with a piece of magnet. Every time you hold a piece of magnet in your hand, you want to test it out whether it will attract something, right? So what do we call the things that are being attracted by a piece of magnet? So when it's attracted, what do we call them? So let's look at this third point. We call this the magnetic material. Magnetic material can be made into magnet. Other magnetic materials, that cannot be attracted, therefore are called the non-magnetic materials. Okay, and just to have you know that there are four types of magnetic materials named on this earth. I give it a short acronym, NICS, NICS. There are only these four categories of magnetic materials, and you have to know them by heart. Any other thing that does not belong to NICS, they are non-magnetic. So let's fill in the left column of your table. First of all, N stands for nickel, I stand for iron, C stand for cobalt, and S stand for steel. Normally, student has no problem with nickel, iron, and steel, but sometimes for C, some students have a tendency to think that it is copper. It is not copper, it is cobalt. All right? Now, how about non-magnetic materials? Non-magnetic materials, I think we have a wide variety of them, okay? Many. Just to give a few, we have wood, plastic, rubber, right? So glass, for example, all these are non-magnetic. Maybe there are some that uh, students that may still have misconception is that they tend to say that all metals are magnetic, all metals can be attracted. That's why I leave point form blank for a while and make you think, okay, to let you think, are there things that are metals but yet cannot be attracted by magnet? Let me pause here for a while and show you a video clip very quickly again. Okay, class, let's take a look at this video clip on uh, some metals that are being tested, and I will check with you what you observe. Are all metal elements attracted to magnets? Iron, aluminum, magnesium, titanium, tin, cobalt, zinc, lead, copper, nickel, gold, silver, platinum. So nickel, cobalt, iron. Notice steel is not within here, but steel can be. Let me go back to your notes now. So what is this fourth point that I want to emphasize? That not all metals are magnetic. And if they are not all metals that are magnetic, who are they? Right? As we have seen from the video clip just now, they are the copper, zinc, brass, aluminum, and if you can recall, also platinum, gold, right? And just try your best to remember that it is only this nickel, iron, cobalt, steel that are magnetic, while the rest are not. Okay? Now, at this point, um, if you have a piece of magnet, which sometimes you can find at the on the fridge door, sometimes you have some paper, this magnetic uh, figures that you attach to the refrigerator door. Just take one of them and try it on all the Singapore coins, new ones and the old one. You will notice that some of the coins cannot be attracted, and these coins probably are made of copper. Some students sometimes ask, what if this is an alloy? Meaning it's a mixture of metal. Now, so long an alloy has some element of magnetic material in it, for example, copper with a little bit of iron on it or steel in it, then this alloy would be able to be attracted to a piece of magnet. Okay? Okay, class. At this point, let's consolidate what we have learned so far. Part A of the objective of the lesson is to uh, be able to describe the three properties of a magnet. Okay, and in these three properties, one of them we have learned is that the uh, a piece of magnet must be able to attract magnetic material. And who are these magnetic materials? Remember, you must be able to recall the magnetic materials are none other than the four NICS: nickel, iron, cobalt, steel. Now, just to let you see how some of these questions may appear in the O level, um, you can now quickly turn to the worksheet behind the notes. Okay, take a look at the worksheet behind the notes, and I would like you to flip to the question behind this page, and let's look at the let's look at question 14 and 18. Can I give you a minute to quickly do these two questions that I run through, confirm the answers with you? You can pause the video clip here and do your work now. Okay, class, let's confirm our answer now. Um, I think you will be able to very quickly verify the answer with me that the first one, number 14, which of the following materials can never be picked up by a magnet? Okay, can never be. Let me enlarge this. Okay, can never be picked up. So I believe the answer is B, right? Can never be. All right, now let's look at question 18. Which of the materials, that means both of them in A, B, C, D, in this process are non-magnetic? Okay, non-magnetic. So I can see that the option B will be the best answer, would be the answer as well. Okay, so that's how some questions can be asked about magnetic materials. These are part of magnetic properties that you have learned in objective A. Let me pause here again. I will now come back to your notes. Okay, class. Now back to your notes again. The second part before we go on to induced magnetism is this thing called the law of magnetic pole, or sometimes we name it as law of magnetism. You have already learned in static electricity that light charges attract or repel? Repel, right? So same thing for law of magnetism. It's nothing new, so I'm going to show you very quickly. Light poles repel, unlike poles attract. Just be very careful that when the question has got to do with this chapter on magnetism, you have to state the law as light poles repel. Because sometimes students are not careful in for the questions of magnetism, they go and say light charges repel. You only use light charges repel when the question has got to do with static charge, not with magnetism. Any words used wrongly will disqualify you for any marks. All right, remember, this topic has got no calculation. Everything about keywords are important. The choice of keywords are important. Okay, so just a quick video clip again, just to make sure that the student who have never played with magnets, if you get a hold of two pieces of magnet, you probably will play this. All right. Okay, so class, look at this video clip very quickly. Probably this is what you will play with when you have two pieces of magnet, right? So light poles repel, Okay, we get the idea, right? Now, light poles attract. So we call this attractive force or attractive magnetic force. And light poles attract. Metallic ball deflected by net. This one are non-metallic balls. How about metallic balls now? Oh, attracted. See again. So this short clip here shows some interesting thing, show an important behavior between a compass and a piece of magnet. Remember, when compass respond to a compass respond, it means a piece of magnet is near to it. And you notice that when he switched the poles near the compass needle will also change. Remember, compass itself is also a magnet. A compass needle is magnetized. So one end is north, one end is south. So when the south pole come towards a piece of south pole come towards compass needle, the north pole of the compass needle, the north end of the compass needle will be attracted to the south pole of the bar magnet, right? And vice versa. But what if a piece of magnetic material is brought near to the compass? How will the compass behave? Have you ever tried that before? I've done a short video clip myself. Let's take a quick look at it also. Okay, now let's take a look at this beginning few seconds of my clip. I'm going to hold up a piece of iron nail, this time not a bar magnet, a piece of iron nail near to the compass needle, and let's see how they respond, okay? Okay. Uh, Everyone noticed that the compass needle, the south end of it, the blue part, the south end of it keep following my iron nail wherever my iron nail goes. Um, any reason? Anyone can explain why? Remember the properties. Um, a piece of magnet must be able to attract magnetic material. The iron nail that I hold in my hand is a magnetic material. The compass needle is actually is a magnet itself. So the south end of the needle, the blue end of the needle, will attract my magnetic material, which is the iron nail. Now, I could have shown it brought near to the other end of the compass needle, which is the north end of the compass needle. It will also respond the same way. Just that I didn't capture that part in this clip. But to ask you if my iron nail is brought near to the north end, how will it respond? Then I think you should believe that it will follow the north end as well, the non-color part, the silver color part will also follow my needle wherever my needle go. So be it north end or the south end of a compass needle, they are magnetic poles. they must be able to attract magnetic material. All right, so regardless of which end, it will follow. Let me now go back to your notes. Okay, so now that you have known the law of magnetism, that unlike poles attract and like poles repel, let us very quickly take a look at this, the next point in this notes. You would have seen this table there very quickly. Look at this table, short activity. I would need you to read this top part, complete the table below to show what happens when a the north pole of a magnet is brought near to the following objects. So the north pole is brought near to the north pole of a magnet. What word would you choose to write here? What would you observe? Would it be no effect, repel, or attract? Can you write that there? What if this north pole now is brought near to the south pole? What will be the effect? Will it be attracted, repel, or no effect? What about to the glass rod and to the soft iron? Can you quickly fill in this choice of words here, and then I will run through the answer with you. I will pause here and let you fill in the answer in a few seconds. Okay, let's look at the answer now. First two, North Pole and North Pole will repel, South Pole and North Pole attract. Glass rod, how do we write? Either you say no effect or there is no effect on the glass rod, all right? Now next, iron rod, soft iron rod. There's a reason why in this chapter we don't call iron rod as just iron rod. There's a reason why there's a word soft in front, but that will be shown to you later in the end of this topic, okay? It will be attracted towards the North Pole, regardless of which pole. South Pole or North Pole come near to it, the soft iron rod will still be attracted, okay? Now, let's think of another important questions here. If I take a look at this question too, use the above results, okay, what you know about attract and repel, basically the law of magnetism, to devise or to think of a method of determining if an object is a magnet or not. So let's say I give you a piece of object. How do you determine whether this object is a magnet or not? I think for a while. Okay, I want to emphasize this word in this answer. Many of you would have thought of bringing another piece of bar magnet to come near to it, but you must be careful to choose the right word. You must see whether the object is repelled by the magnet, not attract. If it is repelled, then it is a magnet. Why? Attract cannot. Many a time students just put very generally as bring a magnet near to it to see whether the object is attracted or repelled to it. That answer will not be accepted. The keywords that we are looking out for is only repelled. Any reason why? Okay, if a piece of object is attracted to another magnet, if the object is attracted to a magnet, does it tell you that the object is also a magnet? It may not be so, because the object, for all you know, the object that is attracted may just be a piece of magnetic material like iron, steel, nickel, or cobalt. They can all be attracted. So being attracted doesn't tell whether an object is a magnet or not. It could just be a magnetic material. However, if it can be repelled, that means that object also has got poles, and that like poles facing the magnet has caused the object to be repelled. Therefore, that tells me that object being repelled also has got poles, and only magnet has poles. So my conclusion, the last statement there, in conclusion, okay? Okay, sorry. So never say attract. So you can write this statement in to remind yourself when testing a magnet. something attracted to a magnet could very well be an unmagnetized magnetic material, such as an iron. Okay, so in conclusion, repulsion is the only sure test for a magnet and its polarity. Polarity means its pole. I want to tell what pole is on which end. You can just use a piece of magnet to test for repulsion. Once it repels, it means that end has got like poles. All right? Okay, I would like to end this video clip at this juncture. Let's name this clip as clip 1, because after this clip, there will be some questions for you to try it out. Thank you. Okay, sorry class, let me not end at there yet. I forgot there are at least 3 questions in the MCQ in the worksheet behind that you can try on to understand how questions are asked with regards to the law of magnetism. Okay, so can you please turn with me to the worksheet behind your notes again. Let us look at 3 questions. Can you look at question 6, and if you turn behind, I would also like you to look at question 9 and 16. Okay, 6, 9 and 16. I give you a few seconds to try. You can pause the video clip now and try these 3 questions in a minute. I will come back to show the answer. Okay, let's look at question 6. Let's read the question first. So, 2 bar magnets come near to each other. Let me enlarge this. Okay, where would a permanent magnetic north pole be? That means this piece of object PQ or XY has got to be a permanent magnet, and it has got the north pole. Okay, it has got to be a north pole. Now, for it to be a permanent magnet, it means all the attract one cannot be an answer already. Remember, only repulsion can tell us whether something is a magnet, and this is the one that shows me the second diagram below. This one from the top will be the one that shows me, which means PQ, okay, is a permanent magnet. That is the first point we can establish. Then number 2, the north pole will be at therefore, for it to repel, here has to be a south, here has to be a north. And therefore, the answer is north pole. Permanent north pole has got to be the P. All right, P. So answer is C. Okay, let's go to the next question. Okay, question 9. All right, a bar magnetic material is already a magnet. Is a magnet if, let's read, both ends of a compass needle are attracted. Again, the word here attracted doesn't sound right to me. Okay, if it's attracted, then this magnetic is just a piece of magnetic material. When a copper needle is repelled, first of all, copper is not a magnetic material. So that copper needle can never show any effect when it's near a magnetic material. So the word copper, it doesn't sound right already. Now the last one is the answer. Okay, one end of the compass is repelled. Right word. Repelled by one end of the compass. Compass, remember, is a magnet. Is repelled by another end of the bar. If it repel, compass is a magnet, and once the magnet is repelled by the end of a bar, that tells me the bar is a magnet. Okay? Let's look at the next one. Question 16. Okay, question 16. NX of a metal rod attracts the end pole of a compass needle. NX attract the end pole of a compass needle. Okay, the end pole nx, nx. Let me erase this. Okay, it's nx. Okay, nx attract the end pole of the compass needle. Remember the word used here is attract. Okay, what does this shows about the rod? The rod. So A, it could be made of copper but is unmagnetized. If it can attract a compass needle, then uh, this metal rod has got to be a magnetic material. And compass and copper, I'm afraid copper is not a magnetic material, so out. Copper again, out. Could be made of steel. Yes, steel is a magnetic material, but it's unmagnetized. That could be an answer. We hold on first. Then D, it could be made of steel with N pole at X. If N pole is at X, then it should repel the North pole of the needle. So this doesn't make sense. So last point also wrong. The answer is C. All right. Answer is C. Okay, that is the end of my part one, really the end of part one of this video clip. We'll have some questions for you to respond in quizzes, and you must submit for me to know your attendance, that you have tried the questions and that you have participated in the lesson. Thank you.